Welcome back to the another session of our data structure journey. Right now we are started the circular double linked list. Last video we are already completed how to create the list as well as how to display. Creation we have completed by help of the insert at the first position of the circular double linked list. Right now we are going to cover insert at the end of the double linked list. You may think that it's a prerequisite that we should be cover the previous video. In description section also I put the link for this video. Try to go through, just brush up the video and continue this video, then it will be easy. Otherwise I will try to explain, but it will better that you just cover this video and just try to win, because the data structure all operation we cannot make a one video. That's why I make like that. So what is a circular double linked list? Circular double linked list is a variation of double linked list where back pointer of first node points to the last node and last node of the next pointer points to the first node, making the loops. Two loops here, two loops. For example, this is our double linked list is present. Double linked list means both the side link can be possible. The information story in the one part, remaining part at the address of next node, address of previous node. First node, there is no previous node, that's why it is not. Last node, no next node, that's why null. And there is two pointer. First pointer points to the first node, that called as the last pointer. Second pointer points to the last node, we called as a last pointer, and both the direction. So this node store the address of next node, that is 200. This node store the address of previous node, that is 100. In this way the linked list is represented. This is called as the double linked list. Now we have to go to the circular, means certain thing is added, that is there should not be any null. So this node points to first one and this node also point to this one. So first we store the address of 400. 400 is the address of last node. Now back of the first node points to the last node. Then what happened? It will make a connection to this node. So now pointer points to this one. Similarly, last node next point to the start. So last node, what is the start address? 100. So instead of null, if we store the 100 address, then what happened? Last node next point to the first node. So now we store the 100. If we store the 100 means immediately it will point to this node. So this is the way we have to design the circular double linked list. In last video, we are already completed how to create and how to display the circular linked list. Right now, we are going to cover how to insert at the end of the double linked list. Means the list now circular linked list is present. Here we have to insert the node. So as this node consists of three elements and we are going to implement in the C language. So structure declaration is consist of three elements. First one is the information and remaining two are pointer. One pointer we make as a next. We store the address of next node. Another pointer name as a back that points to the back. So this is the algorithm how to insert into a end of the circular list. So there are two cases, possible cases. First, what happened whenever we want to insert a data, we have to allocate some memory. At that time, memory may allocated or may not be allocated. Maximum cases memory allocated. Very rare to rarest chances that memory is not allocated. But anyhow, in our cases, we put that if the memory allocation not possible, simple we have to print error message and we have to exit. Otherwise, means memory allocation is done. Then what happened? We have to put into the end of the linked list. But here what happened? Whenever we put into the list, there are two cases possibilities where the list is empty or list has elements. So whenever the list is the empty means initially we initialize the start as well as the last is null. So if the start as well as the last equal to null, then only the list is empty. For example, right now start equal to null value as well as the last equal to store the value of null. That is the initialization. Now we are not created any node. Then what happened? List is empty. So if the list is empty, before that the memory allocation is done. So for example, this is the node is memory allocation is done and the memory allocation address is 500. Here we have first statement. This line we have to follow. Store the data into the information part of the newly created node. For example, we want to store the 11. Make the back and next pointer of newly created node as a new node address. Next thing, why? Reason is that it is a circular linked list. So first node back point to the last node. Right now, what happened? This node is first node as well as the last node. That's why if we store the 500 means now it point to this one. So back of start node point to the last node and last next. So this is also next node point to the first node. So same address we have to store. That's why make the back and next pointer of newly created as the new node. So new node the address is this one. Now point the start and last pointer to the newly created node. Previously what happened? Start. Right now what happened? We have to make it to the point to the newly created node. How to point it means before that that value is null. If we store the 500 means what happened? Now pointer points to this node. Last if I store the 500 then what happened? It points to this one. So now last also point to the. So insertion is over if the end position if the list is empty. So this is same as the insert into the first position. Only changes in this. Now we have to go to the second case, that is list have elements. So if the list have elements, then how to insert into the double linked list? Let us draw a double linked list. So for example, this is one element, this is the another element. Only three element is present. For example, we want to insert. So address is for example 200, 400, 600. Data stored 5, 2, 7. So now it is a circular double linked list. So first node, back store which address? Last node address, so 600. So now it's point to this node. You store the next address 400. This node store the address of previous node 200. Next address 600. Back address, previous address. So it store the address of first address of 200. So now it makes points to this node. So this is our circular doubly linked list. This is the start node pointer. This is the pointer to the last node. So we have to insert. So before that, memory allocation is done. For example, we want to insert the value 10. So memory allocation is done means, for example, address is 100. So we have to store the value of 10. Because here it is mentioned memory allocation, the first line is store the data into the information part store, we store the value. Make the back pointer of new node to the last node. Back pointer of, so this is our new node. Back point to this one means store the 600. Now connection to this one. Make the back pointer of new node. Okay, got it's done. Then next line, this line. Make the new node next. New node next, this one to start node. Points to start node. Okay, start node is 200. So if we store the 200, then now another connection is established. This is to this node. Okay. Then next line, make the back of start node. Back of start node 600, point to the new node. New node means address is 100. So we have to remove this one. When remove means connection also remove. So now we have to store which value? 100. If we make 100 means now this pointer is established. Make the next of last node points to the new node. So what is the last node? Last node right now store the 200 points to this one. But right now we have to make the new node. New node address is 100. So this we have to. So now what happened? Now it store the 100. Then this connection is established. Make the new node as a last node. Now what happened? Last node store which value? 100 value right now. If last node stored to this node previous connection is gone, or we can make this is our last node. Now our insertion is successful or not? Yes, it is successful. Now we have to implement in the C language. So this is our menu drive program. We are already completed the insert into the first position and display in the previous video. This is the series of our circular double linked list. So the first of they are already completed insert. Then we completed the display function, how to display, because it is a double linked list. So we have to print forward direction as well as the backward direction. This is our menu drive program. Case 1, case 2, case 3 we are already written. So right now we have to add one more function, that is insert into the last position. Here we have to insert into the last position. We have to do in description section. I put the link so it will be easy for you to refer the video. So now we have to write down the function, that is the at end. So void insert and so anyhow we have to declare the new node pointer equal to this is the malloc function we have to call. Malloc function we call. We don't know how long it will take the size, so we have to write down the size node. According to that, memory allocation is done. Then we have to check whether the memory allocation done or not. If node equal to null means memory allocation is not done. So we have to write down printf new line memory not done, not done, insertion not possible. It is our choice what you want to print in the output screen. Anything we can put else. Else means memory allocation is done. So what happened if the memory allocation done? Anyhow, we have to store the data part, information part. So we write down new node info. That is the whatever value we enter, that is the num. So before that, we have to read the num value. So we have to write down printf, enter the element into list. Then we have to use the scanf. We have to also declare that is the integer data type. So after that, we have to check whether list is empty or not. How to check list is empty? If start equal to null, it means list is empty. List empty. If list empty, then what are the things we have to do? We have to make the new node. Next is equal to new node. Back, because it is a single node, back equal to which value? Same new node, because it points to the same node. Then we have to make the start equal to last equal to new node. Before that, there is no element right now, only the same element is. Now we have to go for the else means list have elements. Then what are the things we have to do? We have to make the new node. New node back store which value? Last, because we are going to insert in the last node. Then new node, because it is circular list, so it will point to the which node? Start. Then start. Previous start back was the last node, but right now it will point to the new node. So last back equal to new node. Then last next equal to new node. Then we have to make the last as a new node. New node we have to make as a last. Now insert into the last function work is over. Let us add the things into the one more function into the main function. So who is the insert at end of list. Then new line will be created. 3 is for display. Then 4 is for exit. Insert and then case 3. This is 4. Then this is not equal. Let us compile and run whether we are getting any no error. So insert, okay, if we have to go for second option. Enter the element into the list. Okay, we cannot get tab. Okay, no problem. We insert 10, then we store the value 20, then 30. Now we have to go for display. Forward direction 10, 20, 30. Backward 10, 20. Yes, we are getting the correct answer. Only that whenever we insert the limit, it will be, there should be some space. So we have to just make space here. Now we go for display. 10, 20, 30, 40. Now let's try the first one. Insert into the first position. Element is 11, then 22, then 33. Now we have to go for display. After the insert into the end position, this is the previous position. So we are perform the, so it will insert in the first 11, then 22, then 33. This is forward direction, this is the backward direction. Yes, all the three function is executed. Watching the video, please subscribe the channel as well as like and share the channel. Thank you so much.